For this lesson, we're going to be doing another investigation style lesson. So this is going to work a little bit different than some of our lessons in the past. I'm going to give you a bit of an intro of how to do things, and I'm going to do a few examples with you. But how investigations work is you really have to try some of them on your own. So I'm going to go through and I'm going to do an example of each one. And then what I want you to do is I want you to go through and go online and look at the answers and compare your answers with the ones I've written. So what we will be doing here is we will be using DESMOS. And there's two ways to use DESMOS. You can go to this link here and click that. And that is the way to use DESMOS in a web browser. If you have space on your phone, I would highly recommend downloading it. It's just very user-friendly on your phone, but it works exactly the same way if you were to use the web browser as well. So what we'll be doing is we'll be looking at each of these relations, and then we will be graphing it on DESMOS. Using our graph on DESMOS, we're going to be filling in this chart, and we will be making some conclusions. Our end goal is to be able to look at an equation and be able to list the transformations that happened from our original parabola, and to be able to look at an equation and start to be able to picture the graph. So for this first one, I'm going to do these first three with you. So the first one here, if you remember from last lesson, this is our original parabola here. So what we'll do is we'll graph that in DESMOS. And we should have something that looks like this. This is our original parabola with nothing changed to it. So we need to identify a few important pieces. The first thing we want to identify is the vertex. And the nice thing about DESMOS is if I click the vertex, it understands that that's an important point, so it'll give you the coordinates right away. So our vertex is at 0, 0. Next, we have our axis of symmetry. And you don't need to do this part, but I want to show you where your axis of symmetry is. So your axis of symmetry is the line that splits your graph right in half. So I've graphed this blue line here just so you can see, but it's the line that shows that my parabola is symmetric. So if I folded it over top of that line, both my sides would match. And I always write out my axis of symmetry as an equation. So remember, our equations of vertical lines are always x equals lines. And you'll also notice a pattern that will always have x equals whatever this is. So you start to notice a pattern emerging. Next, we want to find out if it was stretched or compressed. So just as a reminder, if something's been stretched or compressed, that's when I have a value right here. And remember, when stretched or compressed, I'm not looking at the sign, I'm just looking at the number. So ignore if it's positive or negative. If it is bigger than 1, we have a stretch. If it's in between 0 and 1, we have a compression. In this case, if I look at my equation here, I have y equals x squared. So I don't have a number in front of that x, so I can just write neither. So if there's no number there, we just write neither. Next, my direction of opening here. If I look, it's a happy parabola and the opening is up. And now domain and range. So these were the two that we very briefly talked about in the first lesson, but I really want to go over them in some more detail. So basically what domain and range are is they are a way of explaining the possible values for your graph. So the idea is that in words, you could describe to somebody all the possible values that x or y can take, and it helps somebody to be able to visualize the graph. So in terms of our x values, there's nothing limiting a potential x value. If I zoom out, there's nothing along the x-axis that could potentially stop an x value from happening. So that means that x can really be any number possible. And how we write that in math is we say x is an element of real numbers. And in normal English, that sentence means x can be any number. There's nothing stopping it. Now, that can be a little bit hard to see, so I actually think range is a lot easier to visualize. So if I look at all my possible y values, we'll notice that the red line is only at the top half of the screen. And the reason it's there is because y cannot be negative. Y can't happen down below the negatives because we have this turnaround point at 0. So how I write that in math is that y is an element of real numbers, but y has to be bigger than or equal to 0. So if I look here, y can be whatever it wants, but as long as that number is positive. So if I look here, we have y values for 2, 4, 6, but there's no line where y is negative. And finally, we want to look at the number of x-intercepts. So if I look at my graph, DESMOS also highlights x-intercepts for you, so it does make it a little bit easier to see those. In this case, we're only crossing the x-axis one time. So let's try the other one together. So the next one is x squared minus 3. So again, we'll start by identifying our vertex. DESMOS is really nice, and it will identify it for you if you click the line. So my vertex is at 0, -3. Then I want to look at my axis of symmetry, so what line cuts this in half? And again, that would be x equals 0, or the y-axis. Now I want to see, is there a stretch or compression? So do I have a number in front of that x squared? Because I don't, I can just say neither. Next is my direction of opening. Again, it's a nice happy parabola and it is facing upwards. Now my domain. So is there anything that's going to stop x? So I look horizontally, nothing happening over here, nothing happening over here. So there's nothing that's going to stop my x values. So we just write x is an element of real numbers. Now for my y's, there are definitely things that will stop my y's. I see it gets lower and lower and lower. It goes down here to -3, and then it turns back around. So what this means is that y can be anything. The only thing is that y has to be bigger than or equal to -3. And then I look for how many x-intercepts I have, and if I look here, I have 2 of them. So give the third one a try on your own, and the solutions will be posted. So you can pause the video here, give it a try, check your solution, and now we'll move on to the second part. So for the next few, I'm just going to do one to get you started, and I want you to try these on your own. It's a very important part of learning how to do this. So for the second one, we're going to be looking at equations in the form y equals ax squared. So let's start with our first one here. We'll have y equals 2x squared, and we have something that looks like this. So again, you want to do the same thing. We're going to identify the vertex. We're going to identify the axis of symmetry. So if I look, what line separates this right in half? X equals 0. Again, you'll notice a pattern between this and this number. Now, stretch or compression factor relative to y equals x squared. Remember, for our stretch and compression factor, we look at that number in front of x. We ignore if it's positive or negative for a moment, and we think, okay, is 2 bigger than 1? Yes. So we say stretch by a factor of 2. Now again, my direction of opening, if I look here, that will be up. My domain, if I look horizontally, there's nothing stopping my x values. So I'm just going to say x is an element of real numbers. Then I need to identify my range. So if I look here, the only thing stopping my y's is that turnaround point. So we will say y is an element of real numbers, but if I look here, y can be anything except it has to be bigger than or equal to 0. And if I click my graph and I look, it only hits the x-axis once. So what I want you to do is try the rest of these. You can pause the video here and give them a try, and double check your answers on the posted solutions. So the next one here is y equals ax plus k. So we're going to be combining a few things here. So this time I'm going to go a little out of order, but we're going to do this one down here just so that you can see some other options. Oops. So here's our equation. And the first thing we want to do is we want to identify our vertex. So if you click that, you'll find your vertex. So our vertex is at 0, -1. Next, we want to find our axis of symmetry. So if I look, the line that separates it is still x equals 0. Now we want to think if it's stretched or compressed. So I look at my little a value here. Because it's a half, and a half is in between 0 and 1, I'm going to say compressed by a factor of a half. Next, my direction of opening. If I look here, my parabola is still facing up. Then I look side to side to see if there's anything that's going to potentially stop my x values, and there's not. So we're just going to, x can be an element of real numbers. Really, it can be any number on this graph. Now for my y's, if I look, the only thing that's limiting them is this turnaround point. It goes down and down to -1 and turns back around. So I know that y can be anything except y is to be bigger than or equal to -1. And then my number of x-intercepts, if I look, I have 2 of them, so I just write the number 2. So we'll try another example together from 4. So we'll try this one here. So again, our process is the exact same. I'm going to start by typing it in. So here is my graph. I start by identifying my vertex. So my vertex will be at -1, 0. Now I want to find my equation, my axis of symmetry. This time, it doesn't really look like that middle y-axis is splitting this in half. So the line that will be splitting this in half is this line here, x equals -1. And remember, that comes from over here. So our axis of symmetry will always be x equals and the x part of our vertex. But that's why, if you look on the graph, because we want to split it right through the vertex. Now, is this stretched or compressed? So to find out if it's stretched or compressed, I'm looking for a number out here in front of the brackets. Because I don't have that, you just write neither. Now my direction of opening, if I look here, it is definitely facing up. For my domain, I look at each side and there's nothing stopping my x values. So x can be any number. Now for my range, I'm going to look here. What is limiting my range? And that's definitely this point here. So it goes lower and lower and lower, gets to 0, and then turns around. So my y's can be anything, but they have to be bigger than or equal to 0. And then if I look, I only have one x-intercept. It only hits the x-axis one time. Okay, so we'll do one of these challenging ones, and then I want you to give this a try on your own. So we're going to do one that has everything all together. So we're going to go through, we're going to do this one down here. Actually, let's do this one here. Just as a few different numbers, so it'll be easier for me to explain. So we have -1/2 y equals -1/2. 1/2 x plus 1 all squared, and then we have our minus 4. Oops, sorry, there's a leftover negative here. Okay, so we should have something that looks like this. So again, we'll start by identifying our vertex. So if I click my vertex, I will have -1 and -4. My equation, my axis of symmetry, is where this is split right down the middle. So if I look here, it is split along that one line, so x is equal to -1. Now, I need to find out if it's stretched or compressed. So I look at this number out front, and I ignore the sign, so don't worry about that negative. I'm just looking at the number, and it's 1/2. So 1/2 is between 0 and 1. So I'm going to say that it has been compressed by a factor of 1/2. And if I look here in comparison to my original parabola, it definitely is a little bit shorter and wider. It's not as tall and skinny. That's another way I know it's compressed. My direction of opening this time is down, and that is due to the negative living in front of the half. So if it's negative, I know it's facing down, and then the number tells me about the stretch or compression. So we just need to look at those two things very separately. Now for my domain, for my x values, if I zoom out, there's nothing on either side that could potentially impact my x values. So my x can be equal to anything. Now for my y's are limited. So I will not have any y values above that -4. So they're all going to be below -4. So y can be anything except y has to be smaller or equal to -4. And now I look for my number of x-intercepts. So does this graph cross the x-axis? No. So I have 0. So now what I want you to do is try to fill out the rest of the sheet and go through the whole process. You'll start to notice patterns emerging. Once you've done that, look at the solutions and fill out the conclusion. But it is very important that you go through and do the whole investigation process to really understand what's going on.